Okay, today we're going to look at some data to examine how to determine if a reaction is first or second order. Now, the first thing you need to do is, here's some data, time versus concentration. And the very first thing we're going to do is graph our time versus our concentration. So I'm going to highlight that information, go to Insert, Scatter Plot, click on Scatter Plot. Now, your graph should look something like this. You'll see kind of an exponential growth. I always delete the series box because it doesn't really tell you any information. And just a little bit about Excel to show you how to put your axes titles in. Click on axes titles, primary horizontal axis. I'm going to do the title below. Time in seconds. Vertical axis, and this is the concentration of NO2, and that unit is molarity. Now we can also add a title. This is the concentration versus time. Now, this graph tells us a little bit of information. First of all, we can see that by changing the concentration, the reaction rate changes because it happens at different times. We actually have a curve. Now, if it was zero order and there was no change in reaction rate when you change the concentration, you would see most of your data points that would look kind of like a straight line at some time, basically how long the reaction takes. Or, since it is experimental data, the data points might be staggered a little bit. But again, you wouldn't really have any relationship here when you graph the data. I'm going to move that graph off to the side. Now we're going to actually try to determine whether it's first or second order by graphing. There's two graphs that we need to make. First of all, we're going to have to copy our time, so highlight the time, right click, copy, and all I'm going to do is press enter, and that'll copy the time. Now we're going to graph time versus the natural log of the concentration. So I'm going to write natural log concentration of NO2. Now the nice thing about Excel is many of these functions like natural log are already built into Excel, so all I have to do is highlight this box, go up to my function here, write equals natural log, parentheses. I can click this cell right here because I want to take the natural log of the concentration, close parentheses, and hit enter. Now you can see that's the natural log of cell C3. I can copy it and drag this down and hit enter, and that gives me the natural log of cell C4, natural log of cell C5, natural log of cell C6, and the natural log of cell C7. So now I can graph the natural log versus time by highlighting it, insert, scatter plot, and here's my graph. Okay, again, while I'm making this graph, series box doesn't tell me anything. Go to layout and add my titles and my axes titles. Okay, so here's my graph for the natural log versus time. Now a couple things I want to do. This graph, it's hard to see any relationship here, and I've got all this dead space in the graph, so I'm going to highlight my graph, go to Format, right click, go to Format Axes. I'm going to change my fixed axes option to -4, so that way it kind of moves my graph up and I can see my data a little bit better. So it's basically starting here with -4. Now, this is the most important thing. Is what we want to do is look at these data points and see how close these data points fit to being a straight line. If a reaction is first order, these data points will be a straight line when you graph the natural log versus time. So I'm going to right click, add a trend line, Okay, for the trend line I want to add a linear trend line. Now here's the most important part. You have to display the equation on the chart, and this is even more important, displayed r² value on the chart. Now an r² value is a statistical tool that will tell you how close all those data points are to being a straight line. So now that I've done that, I can see from this data my r² value is actually very, very close to 1. Okay, however, you can see the data points don't all fit a line. Now in order to determine whether a reaction is first or second order, you have to look at both the graph of the natural log versus time and the graph of 1 over concentration versus the time, and determine which one essentially is closer to being a straight line, or which one has a higher r² value. I'm going to move this off to the side. Now I'm going to make my last graph, which is 1 over concentration versus time. Copy my time again. Now, nice thing again, you can make this function. It's just kind of built into Excel. Just take 1 divided by our concentration, hit enter, copy them, and drag them down, and you've got all your answers right there. Again, insert, scatter plot, done. So now I have to go to layout and add my axes titles. Okay, now once I've done that, again, I want to go back here, click on my data point, right click, add trend line, linear, again go back down here to display equation on the chart, and display r² value. Now we can see from this data that my r² value is 1, so that means all these data points are a straight line. So now I want to compare these two graphs so that we can examine them and determine our rate order. Now, since the r² value 1 is closer to 1 in my 1 over concentration versus time graph, that means that my reaction is second order. Now, a couple important things to note. Again, these boxes we can delete. A couple important things to note. Since our reaction is second order, this slope, the slope of this line, is our rate constant. So the rate constant for this reaction with NO2 is 0.5431. However, if our r² value was greater in our first graph, the natural log versus time, that would mean our reaction was first order, and the rate constant would be the negative slope of that line. So if, let's say, this graph over here had a higher r² value, the rate constant would be 0.0032, not negative 0.0032, it would be 0.0032, because it's the negative slope of this line, which is the rate constant. So hopefully this helps you identify if a reaction is first or second order, and this will help you examine the graphs as you do your labs.